Okay, so welcome to another solution video to our word problem practice questions. In this question, we have some identical small rectangles and they lie within a larger rectangle A, B, C, D. Now, they said that the length of each rectangle is 24 centimeters. Okay, and they want us to find the area of the shaded part. Now the shaded part would be where the rectangles lie. Okay, so let's see. Let's try to look for identical rectangles within this shape. Now we have this shape here, right? Now it's not a rectangle. Okay, so let's see if we could eliminate that. So it's not this piece here. We have this here, this piece, that's not a rectangle. So let's see if we could eliminate that. Okay, by shading. So we could see these rectangles here look pretty similar, right? We have a rectangle here as well, and then we have this piece. Now this piece is not identical to the others, so we'll eliminate that. So you could see where our identical rectangles are. Now, in the question, they told us that the length, so the length of the rectangle would be this longer side here. That length is 24 centimeters. All right, so the longer side of the rectangle is 24 centimeters. Now, to find the area, we need the length, okay, the length, and we also need a width, right, or the breadth. Now the breadth is this shorter side here. Now let's look for clues here to see if we could use something within this shape to find the width of the rectangle. So we have 1, 2, 3, 4, 5, 6, 7 similar rectangles. Let's look at all the width. We have this width here. We have this width here. Okay. This width here. And we have the width of 6. And we have the width of 7. And we notice that the width of 6 and 7 completely makes up one length of rectangle number 5. You notice that? This means that the length of one rectangle is equal to 2 times the width. Do you see that? Great. So we know the length is 24 centimeters. And we know 2 widths make up one length. So to find the width, we would find the inverse of multiplication on this side, just division. We'll do the inverse operation here. Okay, now if you're not sure what is happening here, take a look at our previous videos or go back to your notes and our previous lessons. So we will have the width being 12 centimeters. Okay, 12 centimeters. So we now know that the width of one rectangle is 12 centimeters. Now how is that going to help us? What do we need to find again? The shaded part. So the shaded part is where these 7 rectangles lie. So let's find the area of one rectangle. Area of one rectangle is equal to the length, which is 24, multiplied by the width. And we found that the width was actually half of the length, right? So that's 12 by 24 to give us 288 centimeters squared. Now let's find the area for 7 of these rectangles. We will just multiply the area of 1 by 7 to give us 2016 centimeters squared. Now the bonus question here is, what is the area of the unshaded part? Now to find the area of the unshaded part, we need to find the area of the entire ABCD rectangle and subtract the area of the shaded part. So whichever one you choose to be your length or your width, we're looking at all the lines in the same plane. Okay, so this is horizontal here. Let's look at all the horizontal lines of these shapes. So you're seeing here we have 124 length here. Let me see if I could circle that. So we have this length here, this 24. We have this width here, and we have this 24 centimeters here, making up the entire length of BC. So the length BC is made up of this 24 plus this 12, remember our width was 12, and another rectangle which is 24 centimeters long, right? So when we add those 3 lengths together, you will get the length BC being 60 centimeters. Now let's look at the vertical lines. Let's take CD. Now let's look for these shapes, the vertical lines of these rectangles on the inside that could make up the length CD. So we have this vertical line here, this one here on number 2, and this one here completely make up this length CD. Right? Look at it. This line, and this one. Okay, so let's add those. Right? Let's call that our width. Our width is CD. Alright, and this here is 12 centimeters plus the length of this rectangle, we know that is 24, plus this width here, our width of the small rectangle is 12. Okay, so we have 12, 24, and 12 to give us 48 centimeters. So now we have our length and width of our large triangle ABCD. So let's find that area. The area of ABCD is now 60 centimeters multiplied by 48 centimeters. Right? And this should give us 2,880 centimeters squared. Now, that's not our answer yet, right? Our question asks for the unshaded part. So, the unshaded part would be equal to the area of ABCD minus the area of the shaded part. And this will give us 2,880 subtract 2,016. So the area of our unshaded part is 864 centimeters squared.